In this lesson, we're going to introduce the concept of comparative advantage and show how two people with different abilities can cooperate to increase their wealth. In the last lesson, we introduced Bernie and his cleaning service, and we discussed his productivity and his production possibilities. In this lesson, we're going to introduce a partner for Bernie. Her name is Anne, and she has her own cleaning service. We're going to find out that because of their different abilities, Bernie and Anne can form a joint venture and, in fact, do a lot more cleaning together than they can do separately. Let's begin by looking at Anne's productivity. Let's suppose that Anne has the following unit labor requirements. Anne is able to scrub a room in 5 minutes, and Anne can sweep a room in 5 minutes. The first thing you notice looking at this chart is that Anne is able to sweep and scrub faster than Bernie. We say that Anne has an absolute advantage in the provision of both services. Whenever you can do something with less effort or fewer resources than another person, you have an absolute advantage in the provision of that service. Because Anne can scrub faster, she has an absolute advantage in scrubbing. Because Anne can sweep faster, Anne has an absolute advantage in sweeping. Now, let's suppose Anne spends an hour doing sweeping or scrubbing. What is the maximum output that she could expect? Well, divide 60 minutes, 1 hour, by 5 minutes that it takes to scrub a room, and you get that Anne's maximum number of rooms scrubbed in 1 hour is 60 divided by 5, or 12. Likewise, if Anne wants to sweep for an hour, she can sweep a total of 60 minutes divided by 5 minutes per room swept to get a total of 12 rooms swept. So with Anne's unit labor requirements here and 1 hour's worth of time to work, Anne's maximum output would be given by this table. Just as Bernie can scrub a maximum of 3 rooms or sweep a maximum of 6 rooms, Anne can scrub a maximum of 12 rooms in an hour or sweep a maximum of 12 rooms in 1 hour. We can now take this information and look at Anne's production possibilities schedule. With 1 hour's worth of time, if Anne wants to divide her time between sweeping and scrubbing, what possible combinations of output can she get? Well, let's have a look. Here's a table then that represents Anne's possible output, sweeping and scrubbing. If Anne spends all of her time scrubbing, she can scrub 12 rooms. That means she does no sweeping. If she wants to sweep 2 rooms, that's going to take her 2 times 5 minutes per room for a total of 10 minutes. Subtract 10 minutes from 60 minutes, and that leaves 50 minutes. 50 minutes divided by 5 is 10 rooms worth of scrubbing that Anne can do. 50 minutes is long enough for Anne to scrub 10 rooms at 5 minutes per room. And so forth. The opportunity cost for Anne of sweeping another 2 rooms to bring her to a total of 4 would be a loss of 2 rooms worth of scrubbing. She'd be down to 8 rooms scrubbed. 6 minutes would be, or 6 rooms of sweeping would be 6 times 5 minutes, or 30 minutes spent sweeping, leaving her a half an hour for scrubbing. Divided by 5 minutes is a total of 6 rooms scrubbed. Notice that all of these numbers in this column, 12 and 0, 10 and 2, 8 and 4, and so forth, all of the combinations add to a total of 12. That's because Anne's opportunity costs are 1 room swept for 1 room scrubbed. How did I calculate that? Well, the cost of sweeping a room is 5 minutes of Anne's time, divided by 5 minutes that it takes to scrub a room. That means every room that Anne sweeps is a room she's not scrubbing. Her opportunity cost is constant. The opportunity cost of sweeping 1 room for Anne is 1 room worth of lost scrubbing. Likewise, because of this reciprocal principle, if Anne scrubs a room, that's a room that she's not sweeping. She spends 5 minutes scrubbing. That's the same 5 minutes she could be spending sweeping. So the opportunity cost of 1 room worth of scrubbing is 1 room worth of lost sweeping. Here's Anne's production possibilities schedule. Now, let's convert this production possibilities schedule into a production possibilities curve. Let's draw a diagram like the diagram that we drew for Bernie. I'll clear my pad here, and I'll move these numbers over onto the board so that you can use them for reference. Well, over here I've got Bernie's production possibilities frontier that we drew in the last set of lectures. And to remind us about Bernie's situation, we'll go ahead and put up his equation. Bernie's production possibility frontier is described by the following expression. The total number of rooms that Bernie can scrub is equal to 3, that is if he spends a whole hour scrubbing, minus 1/2 the opportunity cost times the number of rooms that he sweeps. Each room that he sweeps is 10 minutes, and that means that he's giving up 20 minutes divided into 10, or 10 divided by 20, or 1/2 of a room worth of scrubbing. We saw this last time. Every room that he sweeps is 10 minutes worth of time, and that's half of a 20-minute job worth of scrubbing that he's not able to do. The intercept tells you the maximum amount of scrubbing that Bernie can do, and the slope of the line tells you the opportunity cost of a room swept, measured in terms of lost scrubbing. So here's Bernie's equation, and here's his production possibilities curve. Now we can draw the curve for Ann. Well, let's start. If Ann does no sweeping and all scrubbing, then she can scrub 12 rooms. So let's put a dot here in her curve that represents 12 rooms worth of scrubbing and 0 rooms worth of sweeping. If she decides that she wants to do a little bit of sweeping, every time she wants to sweep an additional room, she has to give up a room worth of scrubbing. So that gives us combinations like 10 and 2 and 8 and 4 and so forth. And we get these points all the way down the curve. Every time Ann decides that she wants to sweep an extra room, she loses a room worth of scrubbing, until finally we get down to this horizontal axis where she's sweeping 12 rooms and scrubbing 0 rooms. Notice we can connect the dots here to find Ann's production possibilities frontier. So let's connect the dots. And just like Bernie, Ann's production possibilities frontier is a straight line. What does that tell you? What does it tell you that Ann has a straight line production possibilities frontier? It tells you that her opportunity cost is constant. Anytime she wants to sweep an extra room, she gives up 1 room worth of scrubbing. Why is her opportunity cost constant? It's constant because her time and resources are equally well suited to providing each of the 2 services. Ann would just assume scrub a room as sweep a room. She can just as easily, with her time and talent, do either. There is no change in opportunity cost. If Ann does more sweeping, she always does so by giving up 1 scrubbed room for each additional room she sweeps. Her opportunity cost is constant. Let's look at the curve here and see what we find. The vertical intercept of Ann's curve is going to be 12. That's the maximum amount of scrubbing that Ann can do. Down here, the horizontal intercept is also going to be 12. That's the maximum amount of sweeping that Ann can do with an hour's worth of time. The slope of the production possibilities curve is rise over run, or -1. That is, every additional room that Ann sweeps is 1 room worth of scrubbing that she no longer has time to do. You find the opportunity cost by dividing the number of minutes that it takes to sweep by the number of minutes that it takes to scrub. 5 minutes worth of sweeping divided by 5 minutes worth of scrubbing gives you the opportunity cost of sweeping measured in terms of scrubbing that Ann is not able to do. Every time she sweeps a room, that's a room worth of scrubbing that she gives up. The slope of the curve is -1. Now, one more thing to do before we start talking about comparative advantage. And that is, suppose Bernie and Ann were working independently of one another. What kind of outcome could they expect? Well, here's Ann's production possibilities frontier. The formula is the amount of scrubbing she can do is equal to 12 rooms worth of scrubbing minus the number of rooms that she sweeps. The coefficient on sweeping is 1. -1. That's the cost to Ann to sweep a room. It's 1 room worth of lost scrubbing. Here's Bernie over here, and we know that his production possibilities are represented by this equation. Let's suppose that Bernie and Ann are both running cleaning businesses and that they are working independently of each other. If Bernie and Ann work independently of each other and don't cooperate, then let's suppose that each of them has to sweep the same number of rooms that they scrub. You go to a house and it's got 2 rooms in it. You've got to sweep each room and you have to scrub each room in order to clean that house. So the question is, if Bernie and Ann have to sweep and scrub the same number of rooms each, that is, Bernie has to sweep, say, 2 rooms and scrub 2 rooms, and Ann has to, say, sweep 6 rooms and scrub 6 rooms, well, what numbers are going to work out? What's the maximum number of rooms that Bernie can clean by himself? What's the maximum number of rooms that Ann can clean by herself? Remember, the numbers have to be equal for sweeping and scrubbing for Bernie, and the numbers have to be equal for sweeping and scrubbing for Ann. Well, the numbers that work for Bernie, as it turns out, are 2 rooms. Bernie can sweep 2 rooms, and that takes him 2 times 10 minutes each for a total of 20 minutes worth of sweeping. That leaves him 40 minutes for scrubbing, and since it takes him 20 minutes to scrub a room, 40 minutes divided by 20 means that he has time left to scrub the 2 rooms. So if Bernie works by himself, then he is able to sweep and scrub 2 rooms each. So it looks like that point would be right here on the diagram. Bernie working by himself winds up scrubbing 2 rooms and sweeping 2 rooms. If Ann works by herself and she sweeps 6 rooms, that's going to take her 6 times 5 minutes each is 30 minutes, leaving her half an hour for scrubbing. Since it takes her 5 minutes to scrub a room, she can also scrub the 6 rooms. So Ann working by herself is going to be able to sweep 6 rooms and scrub 6 rooms. Now, if you look over on the board, I'm going to do a summary of this outcome. When they work independently of each other, and each one of them has to sweep and scrub the same number of rooms, then Bernie is able to sweep and scrub 2 rooms in an hour, Ann is able to sweep and scrub 6 rooms in an hour. Here's what you'll notice over on the board. I've done a table of what Bernie and Ann are able to produce when they are not cooperating. When they work independently, Bernie scrubs 2 rooms, Ann scrubs 6 rooms for a total of 8 rooms worth of scrubbing. Whenever they work independently, Bernie can sweep 2 rooms, Ann can sweep 6 rooms for a total of 8 rooms of sweeping. 8 total rooms get cleaned when Bernie and Ann work independently of each other. Next, I'm going to show how Bernie and Ann can increase the profits of their business. That is, how Bernie and Ann can cooperate and clean more rooms together than they can when they work independently. And this is where we come to the concept of comparative advantage. Here we have Bernie, and here we have Ann. And next to each of our players, we have their present production pattern. Bernie is sweeping 2 rooms and scrubbing 2 rooms. Ann is sweeping 6 rooms and scrubbing 6 rooms. Now, we're ready to introduce the concept of comparative advantage. Comparative advantage refers to your opportunity cost relative to the opportunity cost of someone with whom you might trade. We say that you have a comparative advantage in the provision of a particular good or service if your opportunity cost of providing that good or service is lower than the opportunity cost of someone with whom you might trade. Let's use an example now to try to make this concept very clear. We'll start by looking at the opportunity costs of our 2 players and look at who has a lower opportunity cost for providing the service of scrubbing. Let's start with Bernie. If Bernie scrubs a room, it takes him 20 minutes. Now, since it only takes him 10 minutes to sweep a room, Bernie's opportunity cost for scrubbing 1 room is 2 rooms worth of sweeping that he's not doing. So that's his opportunity cost. Now, you can also express this by dividing both sides by 2. His opportunity cost of sweeping 1 room is half a room that he doesn't then have time to scrub. So the opportunity cost for Bernie of scrubbing 1 room is 2 rooms worth of sweeping that he doesn't do. Let's look now at Ann's opportunity cost for scrubbing. Ann takes 5 minutes to sweep a room and also 5 minutes to scrub a room. So the opportunity cost for Ann of scrubbing a room is 5 minutes worth of time, which means sweeping 1 room. So if Ann scrubs a room, it's because she's not sweeping a room. Her opportunity cost of scrubbing 1 room is 1 room that goes unswept. Given this information, we know who has a comparative advantage in scrubbing. For Bernie, scrubbing costs 2 rooms worth of sweeping. For Anne, scrubbing costs only 1 room worth of sweeping. Anne has a lower opportunity cost for scrubbing, and therefore Anne has a comparative advantage in providing scrubbing services. Well, why should you care? Why should you care that Anne has a comparative advantage? Because comparative advantage is a guide to how Bernie and Anne can specialize and therefore increase their wealth. By specializing in trading, Bernie and Anne can clean more rooms than they can working independently. Let me show you how this works. Let's suppose Bernie decides to reallocate his time and specialize in sweeping, that is, to do more sweeping and less scrubbing. Why am I having Bernie do more sweeping and less scrubbing? Because scrubbing is relatively expensive for Bernie to do. He doesn't have a comparative advantage in scrubbing. He would like to work out a deal where Anne does more scrubbing because her cost is lower. Bernie will do more sweeping because his cost for sweeping is lower. Remember, when Bernie sweeps a room, he only gives up half a room worth of scrubbing. Anne gives up a whole room worth of scrubbing. So Bernie has a comparative advantage in sweeping, just as Anne has a comparative advantage in scrubbing. So let's have Bernie specialize according to his comparative advantage and see what happens. Well, first thing that happens is Bernie reallocates 20 minutes of time away from scrubbing and instead winds up sweeping 2 additional rooms. So with his newly allocated time, Bernie adds 2 rooms worth of sweeping and loses 1 room worth of scrubbing. Well, now he's sweeping 4 rooms and scrubbing 1. So he needs a little bit of help here from Anne in order to make sure that he's getting a full house cleaned. What he does then is he offers to trade with Anne 2 rooms worth of sweeping, those newly created 2 rooms, and see if Anne will give him some scrubbing in exchange. So what Bernie does then is give some sweeping services to Anne. He sweeps 2 rooms for her. Well, this now frees Anne not to have to sweep those 2 rooms herself. And with those rooms not having to be swept by Anne, she has 5 minutes here and 5 minutes here that she can now reallocate towards scrubbing. So Anne sweeps less and scrubs more. She moves this time into scrubbing and increases her scrubbing activity as she cuts back on her sweeping. So now Anne is sweeping 4 rooms, plus she's getting 2 rooms worth of sweeping services from Bernie, and that allows her time to scrub a total of 8 rooms. She can now give one of those scrubbed rooms to Bernie, that is, scrubbed one of his rooms, and he's just as well off as he was before. Now with this help from Anne, Bernie has 2 rooms scrubbed and 2 rooms swept. He's also sweeping 2 rooms from Anne, so she can scrub 2 additional rooms. And if you look, our total output now is 8 rooms worth of sweeping and 9 rooms worth of scrubbing. Where did this extra room of scrubbing come from? It came from specialization. Because Bernie specialized according to his comparative advantage, these 2 working together were able to scrub an additional room. They were able to turn out a little bit of extra labor relative to what they did before. So now Bernie and Anne have 8 rooms swept and 9 rooms scrubbed. Can they do any better? Well, probably so. Right now we've got an unequal number of sweeping and scrubbing, so we've got this scrubbed room that's unswept. Let's see if we can do any better. Well, of course we can, and what should we do? We should have Bernie do even less scrubbing. That is, here's the room that Bernie's still scrubbing. Let's have him take those 20 minutes and sweep instead. That way he can turn out 2 more rooms worth of sweeping services. This promises to be a good deal. Now Bernie is doing no scrubbing at all. He's doing all sweeping. He's got 1 room worth of scrubbing services from Anne that he's acquired, and now he's ready to give Anne 2 more rooms worth of sweeping. Once he gives her those 2 more rooms, Anne is now freed to scrub some more. She converts her time from sweeping away to scrubbing, and now we've got all these scrubbed rooms that Anne has done, and she can send one of them over to Bernie Bernie's just as happy as he was before. He's got 2 rooms swept, 2 rooms scrubbed. Ann is scrubbing both of these rooms for him, and he is sweeping these 2 rooms plus 4 more rooms from Ann. But the total now that we've got here is 1, 2, 3, 4, 5, 6, 7, 8 rooms swept, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rooms scrubbed. Well, we've got a little bit of an imbalance here, and the imbalance is that we've got more rooms scrubbed than we have swept. If Ann wants to be able to sweep and scrub equal numbers of rooms, then she might want to convert one of these scrubbings back into a sweeping so that she now has equal numbers of rooms swept and scrubbed. Well, look at this. Ann has now got a total of 1, 2, 3, 4, 5, 6, 7 rooms swept, 1, 2, 3, 4, 5, 6, 7 rooms scrubbed. Bernie has 2 rooms swept and 2 rooms scrubbed. By cooperating and specializing according to comparative advantage, by Ann doing more scrubbing and Bernie doing more sweeping, and by trading with each other, Bernie is just as well off as he was before, and Ann is better off than she was before. Now, is that necessarily going to be the case? Well, not necessarily. I mean, certainly since we have 9 rooms clean now instead of 8 before, the 2 of them combined are able to make more money with their cleaning business. Ann could stay where she was before and leave Bernie with 3 rooms clean, and Ann would still have the same 6 rooms swept and scrubbed as before. It doesn't really matter who gets the benefit. That will be determined by which of these 2 is a more persuasive bargainer. But the point that I want to make is this. By Bernie specializing according to his comparative advantage, and by Ann specializing according to her comparative advantage, the 2 of them working together, specializing and trading, are able to produce 9 clean rooms, 9 swept, 9 scrubbed rooms, rather than simply 8 as before. Now, let's take a look at the production possibilities frontier and show how this story translates into a graph. Remember these production possibilities diagram. Here's Bernie's and here's Ann's. The slope of Bernie's production possibilities frontier is minus 1/2. That's the opportunity cost of sweeping measured in terms of lost scrubbing. Ann's opportunity cost is -1. That's her opportunity cost of sweeping in terms of lost scrubbing. Because sweeping is less expensive for Bernie, we had Bernie specialize in sweeping services. And we showed that we could get a large increase in total output if we had Bernie completely specialize in sweeping. So here's what we're going to have Bernie do. Rather than staying at sweeping 2 rooms and scrubbing 2 rooms, let's have Bernie completely specialize in sweeping, the task in which Bernie has a comparative advantage. So Bernie's production point now moves all the way to the end of the production possibilities frontier. Bernie completely specializes in sweeping. So here's Bernie's new output point right here. It's at the end of the production possibilities frontier where Bernie is now sweeping 6 rooms and scrubbing 0. We had Ann then specialize by moving up in this direction. Ann reduces her sweeping, taking advantage of Bernie's low-cost sweeping, and Ann scrubs instead. Ann moves her production point up to this dot on her production possibilities frontier. Ann winds up scrubbing 9 rooms and sweeping only 3 rooms. When she does that, she's able to take advantage of Bernie's low-cost sweeping and increase the total number of rooms that she cleans. Now, if you'll have a look over on the board, you'll see our totals with trade. With trade, Bernie sweeps a total of 6 rooms and scrubs 0. Ann sweeps a total of 3 rooms and scrubs 9. The total number of scrubbed rooms is 9 plus 0, or 9. The total number of swept rooms is 6 plus 3, or 9. Working together, Bernie and Ann are able to sweep and scrub a total of 9 rooms. Looking at this picture, how could we have known that Bernie was going to wind up specializing in sweeping services? Well, we would know because Bernie's production possibilities frontier is flatter than Ann's. His slope is -1/2, Ann's is -1. Because Bernie's production possibility curve has a flatter slope, we know that Bernie's opportunity cost is smaller for sweeping than Ann's is. Bernie has an opportunity cost of 1/2 room scrubbed. Ann has an opportunity cost of 1 whole room scrubbed. Therefore, Bernie will specialize in sweeping because he has a comparative advantage in sweeping. Ann will then specialize in scrubbing. Now, finding the exact numbers where this story worked out requires a little bit of puzzle solving. I had to figure out, well, if Bernie specializes, that's 6 rooms worth of sweeping, so Ann has to do at least 6 rooms worth of scrubbing, which leaves her 6 times 5 is 30 minutes from an hour. That leaves Ann 30 minutes or half an hour for additional work. And since 6 and 6 is already taken care of, then she would have to split that remaining time between sweeping and scrubbing. And that's how I wound up with her sweeping 3 rooms and scrubbing 3 additional rooms for a total of 9. So that took a little bit of puzzle thinking. I had to do a little logical problem solving to get the actual numbers. The things you should learn from looking at the diagrams are as follows. First, the trader that has a flatter production possibilities frontier will have a comparative advantage in providing the good or service that is written on the horizontal axis. Here, Bernie has a comparative advantage in providing sweeping services because his opportunity cost is lower in terms of scrubbing than Ann's opportunity cost. The next thing to notice is that if you have a comparative advantage in one good, you have a comparative disadvantage in the other good. Bernie has an opportunity cost of 2 rooms worth of sweeping for every room of scrubbing he does. Ann can scrub a room by only giving up 1 room worth of sweeping. Because these slopes are reciprocals, if you have a comparative advantage in one good, you have a comparative disadvantage in providing the other good. Just as Bernie has a relatively low opportunity cost for sweeping, he has a higher opportunity cost than Ann for scrubbing. All right, so you've always got a comparative advantage in something. Even though Ann can sweep and scrub faster than Bernie, Bernie is relatively better at sweeping than he is at scrubbing. And therefore, his opportunity cost is lower, and that's why he and Ann can get together and make a deal that benefits both of them. It's not driven by absolute advantage. The story is driven by comparative advantage. And no matter how unproductive you are, you always have a comparative advantage in something. Even though Bernie has higher costs for providing all services and Ann can do everything faster, Bernie is still relatively less unproductive at sweeping than he is at scrubbing. And that's how he and Ann can get together and make a profit. The last thing to notice is that by getting together and trading, Bernie is able to make a deal that's satisfying to him. Before, he was sweeping 2 rooms and scrubbing 2 rooms. Now that he's completely specialized in sweeping services, he would be willing to trade as many as 4 rooms worth of sweeping to get 2 rooms worth of scrubbing in exchange. That would put him right back where he was before. And Ann is happy to give him 2 rooms worth of scrubbing because that would leave her ahead of where she was before. So once Bernie specializes according to his comparative advantage, there's room for him and Ann to work out a deal that makes one or both of them better off. That's the magic of comparative advantage. By people specializing according to comparative advantage, everyone who's trading can gain. In the next example, we'll use a story that sounds a little bit more like the international trade stories you read in the newspaper. We'll look at 2 countries that are producing 2 agricultural products and show that by specializing in trading, they can both be made better off.
Let's move on and talk about the concept of allocative efficiency. We've talked about production possibilities and how all points on the PPF are productively efficient, but which point on the curve is the best point? This is what we will determine using the concept of allocative efficiency. The best point on the production possibilities frontier is the point at which goods are produced in quantities that provide the greatest possible benefit. I'll expand a bit more on the concept of benefit in just a bit. Allocative efficiency is achieved when goods are produced at the lowest possible cost and in quantities that provide the greatest possible benefit. In order to understand the concept of allocative efficiency fully, we'll need to introduce a few new concepts. The first new concept is known as marginal cost. Marginal cost is the opportunity cost associated with producing an additional unit of a good. In the graph to the right, we are assuming that we have an economy that produces only cola and pizza. The opportunity cost of producing more pizza is different on every point on the frontier. In fact, as we produce more pizza, we have to give up more and more cola every time. Let's calculate the marginal cost of pizza going from point B to point C. We use the rise over run method to calculate the slope of the PPF, which in turn gives us the opportunity cost of producing an additional unit of pizza. The change in cola, which is on the y-axis, is -2, and the change in pizza, which is on the x-axis, is 1. -2 divided by 1 is equal to -2. Thus, the marginal cost of producing pizza at point B is 2 units of cola. We are giving up 2 units of cola to produce 1 unit of pizza. We can do this calculation for every point on the PPF, and we can graph all the values we get for marginal cost. As you can see on the graph to the left, marginal cost is increasing. This is based on the premise that we have to give up more and more cola each time we want to produce an additional unit of pizza. I mentioned the word benefit before, and I will now expand a little bit more on this concept. Marginal benefit is defined as the benefit received from consuming an additional unit of a good. Benefit is subjective because people's own personal preferences affect the benefit they receive from consuming an additional unit of a good. The marginal benefit curve on the right shows the relationship between the benefit received per unit of pizza consumed and the number of units of pizza consumed. It is clear that the benefit received from consuming each additional unit of pizza is decreasing. We can thus say that the marginal benefit of consuming pizza decreases. This phenomenon is known as the law of decreasing marginal benefit. It applies to almost all goods in an economy. The more we consume of a good, the less benefit we gain from consuming even more. Marginal benefit is measured by the maximum amount of money that someone is willing to pay for an additional unit of a good. Let's define allocative efficiency in concrete terms by using the concepts of marginal benefit and marginal cost. The best point on the production possibilities frontier is the point at which we cannot produce more of one good without giving up some other good that provides greater benefit. The graph on top is simply the production possibilities frontier, and the graph on the bottom is simply that of the marginal benefit and marginal cost curves that we have just seen. In this first case, where we produce 1.5 units of pizza, the marginal benefit of producing pizza is greater than the marginal cost. This means that someone values that pizza and is willing to pay for it at a higher price than it costs to produce. We would get more value from our resources if we were to produce more pizza and less cola. The second point, where we produce 2.5 units of pizza, is the point at which we can say we have achieved allocative efficiency. Marginal cost is equal to marginal benefit, thus we cannot produce more pizza without giving up cola, which we now value more. The third point, at which 3.5 million pizzas are produced, is a point where the marginal cost of producing pizzas exceeds the marginal benefit. Pizza production costs more than people are actually willing to pay, so our resources would be better used if we produced less pizza. The point of this slide is to illustrate to you that the best use of our resources is at a point where the marginal cost of producing a good is equal to the marginal benefit of consuming that good. That in turn leads us to the best point on the production possibilities frontier of our economy.
So now we have a choice between two alternative possibilities.
we can either choose one thing or another, but not both. For example, we could choose to spend our time knitting or walking, but not both. How do we know what the best economical choice is? By calculating the opportunity cost of each choice. Opportunity cost is a relative concept, which means that you're finding out how much of one thing you can produce in comparison to another thing. For example, if the two goods you're interested in are rice and wheat, then the opportunity cost of producing rice will always be in terms of wheat, and the opportunity cost of producing wheat will always be in terms of rice. The opportunity cost of choosing one possibility is the value of the possibility you gave up. It's what you sacrificed. It's not what you chose, but it's the next best alternative. Let's look at how to calculate opportunity cost using land as an example. In country A, we can use the same amount of scarce resources to produce two things, but we can only choose one thing at a time to produce. Let's say the two things we produce are corn and beef. We can use land to either produce corn or produce beef. The next thing we need to know in order to calculate opportunity cost is how much corn could we produce compared to how much beef we could produce. And remember that we're using the same amount of resources, so this kind of a problem really is going to give us the basis for comparing two alternative choices. Let's say that in country A, we can either produce 50 tons of corn, or as an alternative, we can produce 25 tons of beef. This is our trade-off between producing these two things. Now we have all the information we need to calculate opportunity cost. But we need to know which opportunity costs we're trying to measure based on which possibility we want to choose. Let's start by looking at it from the corn perspective. The opportunity cost of producing 50 tons of corn is equal to how many tons of beef we could have produced, which of course is 25 tons. Therefore, the opportunity cost is found by solving this equation. 50 tons of corn equals 25 tons of beef. What we really want to know is how much beef we could have produced if we chose to produce 1 ton of corn. But the question gave us 50 tons. To reduce this equation down.
So, what do graphs have to do with economics? Well, they provide a very useful way to build a simplified visual of how the world works. Okay, since economics is all about the choices that people make, let's look at an example that all of you have in common, how a student taking an economics class chooses to use his or her time. Let's make a couple of assumptions about our student. After carefully evaluating for time spent at work, sleeping, eating, social activities, family, there's 10 hours of study time each week. Also, data shows that most students who take economics are full-time, so let's assume that this student is taking a second course. I know, in the real world, full-time means 4 or more courses, but I'm going to limit the number of classes to 2. For one, it's hard to draw a diagram in 3 dimensions, and I'd like to see you try 4 or 5. For another, you'll see that even assuming only 2 classes, we can use this simplified model to illustrate how people make their choices. Now, what's the measurable objective of the student who's taking 2 classes, let's say economics and math, and has 10 hours per week to study? Grades. How well the student is doing is measured by grades. So let's put all of this information in graphical form. First, I set up my 2 axes and label each. One will be the grade in economics, the other will be the grade in math. What's the possible range of grades? Well, anywhere from an F to an A, or since we're counting on this graph, anywhere from 0.0 to 4.0. This is true for the grade in economics axis as well as the grade in math axis. Now, our student goes to classes on the first day. Math class isn't very stimulating, but the econ class is great. You go home, check Blackboard, rewrite your notes, do the practice sets, form a study group, and before you know it, your 10 hours are gone. If indeed you put in 10 hours per week in economics, it's quite likely you'll get an A. But this leaves you with 0 hours to work on math. If you do no studying or homework for math, you're going to get an F. This is our first point on the graph. What if you begin to spend a little time each week on math? Maybe you start spending about 2.5 hours on math and cut back to 7.5 hours in economics. Well, the math grade is going to go up, and that's good news. Now you're at least getting a D in math. But because you took time away from economics, the economics grade is going to fall from an A to a B. And so on. I can follow this pattern. If I were to spread my time such that I was using 5 hours for each class, I would get a C in each class. If I decide to spend 7.5 hours on my math class, leaving me with only 2.5 hours for econ, the good news is my math grade's up to a B, my economics grade's down to a D. Finally, I could spend all 10 hours on the math class, giving me an A in the math class, which is great, but that leaves me nothing to study for economics, and now I'm failing my economics class. Are there any other combinations the student could choose? Sure. He or she could pick, 7 hours and 3 hours, or 6.2 hours and 3.8 hours, or 1 hour and 9 hours. There are an infinite number of combinations. These would be shown in the diagram between the points we've already chosen. Did you notice that once we've included all the points, this looks more like a solid downward sloping line than just some collection of points? This is a production possibilities curve, or PPC, also referred to as a production possibilities frontier, or PPF. By definition, the PPC, or PPF, shows all possible combinations of output that can be produced, assuming two things. One, a fixed amount of productive resources of a given quality, and two, efficient use of those resources. Well, did we do all this stuff? Yeah, we looked at all possible combinations of output by examining all possible combinations of grades that were being produced. Fixed amount of productive resources is 10 hours of the student's labor, and efficient use of the resources, well, by definition, efficiency means that there's no unused or wasted or unemployed resources, and with every combination we made sure that the student was using all 10 hours, so there's no unused study time. The production possibilities curve illustrates the positive analysis, all possible ways in which the student can choose to use his or her time. Now for the normative question, what combination will the student choose? What point will the student choose? Well, it depends on the decision maker. A student might choose a C in both classes because at least they'd be passing both classes, but what if the GPA in your major matters more than your overall GPA? If you're a business student, you might choose a B or an A in economics then over a passing grade in math. Well, I can tell you aren't satisfied with these choices. You're thinking, can't I get an A in both? No. Under the current assumptions, 10 hours of study, this combination is currently unattainable. Could I ever get there? Well, sure, if you can get some more time from somewhere, those additional 10 hours somehow. Maybe if you cut back at work or dropped another class or stopped sleeping, I don't know. Could the student choose, say, a D in both classes? Certainly, but you're wasting your resources. You're not using all of your study hours for the intended purpose, which is getting the grades in the classes. So you see, even our very simple graphical model tells us a lot about how a person with more needs than resources must make decisions. Next time, opportunity. One outcome of the production possibilities model that's tough, yet very real world, is that without acquiring more resources, in order to get more of one kind of output, like a better economics grade, you must sacrifice some of the other output, like your math grade. This sacrifice is a fact of life, folks. It's called opportunity cost. By definition, opportunity cost is the highest valued foregone alternative when any choice is made. Look, think back to the example of the student. What was the opportunity cost of getting a better grade in economics? The student would have to accept a lower grade in math, so the sacrifice was the math grade. The full cost of any choice is not just the price tag. Although that direct out-of-pocket monetary cost does influence our decisions, the full cost also includes the opportunity cost. What gets sacrificed? That is to say, what else could you have done with your resources? Okay, here's an example of a choice that you have in common with the rest of the class. You opted to go to college. What is the full cost of that decision? Remember that the full cost of attending college is the sum of the direct, those out-of-pocket costs, and the indirect or opportunity cost. Is the opportunity cost really all that important? Can it influence a decision one way or another? Well, let's think it through and then decide. What are the direct costs of attending college? That is, what out-of-pocket costs will you incur? Tuition, registration fees, books, supplies, etc. Now, what are the indirect costs of attending college? That is, what could you have done with your time and energy if you weren't in college? What is it that gets sacrificed? Note that opportunity cost doesn't necessarily have to have a specific dollar price tag attached, just a value. Well, it might be that you could have been working. If this is the case, you could be sacrificing salary and or career advancement. Possibly you're giving up time that you could be spending with friends or family. For myself, one thing that was sacrificed was starting a family. I waited until I was finished with grad school to have a baby. Or maybe travel, or just leisure time. In the late 1990s, my husband worked at a .com, and he'd tell me how every day for 3 weeks, the newly hired CEO would stare out the window during meetings and mumble, "I could be out playing golf right now." Then the CEO quit. The decision to go to or stay in college is similar. If the opportunity cost is too high, the decision maker will decide not to attend. This often occurs with college athletes. If professional teams will hire them, then they could be sacrificing millions by staying in college. As a result, top athletes often leave college early for the pros. Going back to the original question, what is the opportunity cost of attending college? Well, it depends. Remember that by definition, the opportunity cost is the single highest valued alternative to that particular decision maker when any choice is made. The opportunity cost then varies from person to person. I even had a friend in college whose boyfriend, upon dumping her, informed her that she was the opportunity cost of attending college. She never cared much for economics after that. What is your opportunity cost of attending college? Even with all the costs associated with attending college, you decided to attend anyway. Why is that? Next time, society's production possibilities.
Meet Lilith. She owns a small startup tech company that manufactures smartphones and tablets. Lilith has some important business decisions to make concerning the allocation of her company's resources over the next fiscal year. A large part of her decision-making analysis will concern calculating and assessing opportunity cost. You can think of opportunity cost as the benefit or value you give up by picking one course of action over another. In other words, the opportunity cost of a decision is the difference between the value you receive from pursuing a course of action and the value that you would have received from the alternative you did not pursue. Let's look at Lilith's tech company to illustrate the concept. Lilith can use one day to manufacture either 100 smartphones or 75 tablets. If she chooses to manufacture the phones, the opportunity cost is the difference in profits of producing 75 tablets. On the other hand, if she chooses to manufacture the 75 tablets, it costs her the difference in profits of manufacturing 100 smartphones. We generally want to analyze opportunity costs in terms of investment, whether it's a person or a business making that investment. We can express opportunity cost in terms of a return or profit on investment by using the following mathematical formula. Opportunity cost equals return on most profitable investment choice minus return on investment chosen to pursue. Unless the investment returns are fixed and practically guaranteed to be paid, like a U.S. Treasury bond you intend to hold to maturity, you'll have to base your calculation on the expected returns. For example, on average, the stock market may have an annual return of 8%. But that doesn't mean your stock portfolio will return 8% this year. Now let's apply the formula to an example.
Lilith's company has a 10% return when it sells smartphones, but an 18% return when it sells tablets. Let's plug in the numbers and see what happens. Opportunity cost equals return on most profitable investment choice minus return on investment chosen to pursue. Opportunity cost equals 18% return on tablets minus 10% return on cell phones. Opportunity cost equals 8%. If Lilith orders the production of smartphones, she'll have to give up the opportunity to earn an extra 8%. Of course, we are assuming that there is sufficient demand for tablets to expend all Lilith's production capacity on tablets. You can use an opportunity cost analysis to help you decide how to best capitalize a business. A business's capital structure is simply how a company finances its operations. Capital structure may involve a mix of long-term debt, short-term debt, and equity. Equity is the infusion of capital into a business through the sale of shares of common stock or preferred stock to investors.
So now you know that graphs can be used to illustrate an individual's choices. What about the choices facing a society? Well, who makes decisions on behalf of society? The government. What kinds of things does our government provide for us? Well, they provide things like roads, education, national defense, our justice system, research, unemployment benefits. The government's trying to do an awful lot of things for us all the time. In a sense, the government is just like us. They're trying to fulfill this many needs with this many resources. So, how do I tell this story using a graph? First, I want to narrow down the categories of things that the government tries to provide to two. Why only two? Oh yeah, I can only draw two. Okay, let's say that our society has two categories of goods and services. Military, things like national defense, anti-terrorism programs, etc. And civilian, which might include roads, parks, or low-income support. You, as the economic analyst, have no say in what the society should do with its resources, but you can examine what we could do. If society takes every bit of its resources, all the land, all the labor, all the capital, and all the entrepreneurial ability, and puts it into the production of military goods and services, let's say that we can produce 5,000 units of military output. But this leaves no resources to produce civilian goods, so we would have 0 units of civilian output. Note that I'm not making any judgment as to whether this is a good idea or a bad idea, just that it's a possible choice that can be made. What if you want to consider having some roads or schools or parks? Let's say that you're considering building 1,000 units of civilian goods, maybe 1,000 schools or 1,000 miles of road. Where will the resources to produce 1,000 units of civilian goods come from? That's right. You'd have to take the resources away from military production. So military must decrease, let's say to 4,800 units. What's that? You think I've made some kind of a mistake? How could I possibly gain 1,000 units of civilian goods and only sacrifice or have an opportunity cost of 200 units of military goods? Well, consider this. What if civilian represents elementary schools and military is stealth bombers? Which one do you think takes up more resources? There's no reason why there would have to be a one-for-one trade-off. In fact, it would be unrealistic and restrictive to assume this. Okay, so what if I want more civilian goods, 2,000 schools or 2,000 miles of road? Then what? Yep, we would have to shift more resources away from military production, so that now civilian is 2,000, but military is only 4,500. This time you're sure I've made a mistake? How could I have sacrificed only 200 military initially, but now I'm giving up 300 military? No mistake. Instead of constant opportunity cost, as we had with the grades example, we now have increasing opportunity cost, where our sacrifice will just keep getting bigger and bigger. A PPC that shows increasing opportunity cost is actually much more representative of how the world works. It happens when resources are not as perfectly well suited for one type of production as the other. I'll come back to this in another video segment. Following this pattern of increasing opportunity cost, let's complete the table. To get 3,000 civilian goods, you drop to 4,000 military. To get 4,000 civilian, you drop to 3,300 military. To get 5,000 civilian, you drop to 2,000 military. And if you use every bit of society's resources for civilian output, you'll have 6,000 units of civilian goods, but not have any resources left for military production. Again, as the economic analyst, it isn't your job to decide which of these combinations is good or bad. So, who does get to decide? That's right, the government. Let's say that you're not only an economic analyst, but you're also presenting your data to the White House. Visuals are good, so take a few minutes now to pause this video and map out the combinations with military on the vertical axis and civilian on the horizontal. Hopefully, yours looks something like this. Again, it illustrates the inverse relationship between military and civilian production. The bowed-out shape shows the increasing opportunity cost. You bring your charts and figures and explain to the President, Mr. or Mrs. President, this is the production possibilities curve, sometimes referred to as the production possibilities frontier, since it shows the outer limit of what can be produced with our current resources. What point will the President pick? Right again, it depends. Depends on what? Well, it could be any number of factors. Political ideology could determine where the President would pick. Your typical or average Republican, if there is such a thing, tends to lean more toward military. This is classic Reagan behavior. Democrats are often viewed as spenders, more on social programs closer to the civilian axis. Could be world events. In the early 1990s, after the fall of the Berlin Wall and the Soviet Union, we moved away from the military axis. But after 9/11, we moved toward the military axis. So, the President thinks it over carefully and finally says, I choose point H. What do you tell the President? Hopefully, you're making your response respectful, because after all, this is the President. So how about something like, oh, I'm sorry, Mr. or Mrs. President, but perhaps I've miscommunicated something to you. This line, the production possibilities curve, represents the outer boundary of what we can produce right now, even if we use all of the available resources. To which the President responds, ah yes, you did make a mistake, but I see now. I choose point I. What do you tell the President? Well, Mr. or Mrs. President, you certainly could choose point I, but then we would have resources going to waste. In particular, you might point out that unused resources are unemployed resources. More specifically, unemployed labor makes for unhappy voters. That usually works with politicians. The point is that while you, the economic analyst, do the positive analysis, ultimately the government decides where we should produce, the normative analysis. You demonstrate the possible outcomes, and it's up to the policymakers to make the final choice.
In this section, I wanted to touch on the gains that can be made from trade. This is generally more applicable in macroeconomics and international trade, but it is part of basic economic theory, so I will introduce it now. Specialization is this idea that when we start producing either one or only a few goods, taken in the context of a country, it is possible for a nation to specialize in the production of, let's say, only one good. If this happens, that country will gain insight into more efficient ways of producing that one good, as all its resources are diverted to producing only that one good. This often results in a greater level of efficiency in production and thus lower prices for consumers. Comparative advantage is defined as the ability of one producer to produce a good at a lower opportunity cost than another producer. Oftentimes, this is associated with efficiency. If one producer has a comparative advantage compared to another, they can be said to be more efficient at producing the good. Absolute advantage, on the other hand, deals with overall productivity. If producer A can produce more of a good, regardless of their efficiency, than producer B, then producer A is said to have the absolute advantage in the production of a good. The concepts that I have just mentioned are a little complicated to understand, so here is an example that will hopefully clear things up. Imagine an economy with two producers. Producer A is Joe, who runs a clothing factory. He only has one sewing machine in this factory, so he isn't technologically advanced as he otherwise could be. Joe can produce in a given hour either 6 pairs of socks or 30 t-shirts. He can't produce 6 pairs of socks and 30 t-shirts. He can only produce 6 pairs of socks or 30 t-shirts. We will say that he can also produce some combination of t-shirts and socks that satisfy his time constraint. If we do the math, we can say that it takes him 2 minutes to produce a t-shirt and 10 minutes to produce a pair of socks. If we want to know the opportunity cost of producing a pair of socks, we need to think of the best alternative Joe has with the 10 minutes it takes him to make those socks. In 10 minutes, Joe can also produce 5 t-shirts. Thus, the opportunity cost of producing a pair of socks is 5 t-shirts. Similarly, in the 2 minutes it takes Joe to produce a t-shirt, he could have produced a fifth of a pair of socks. I get it, it's not a complete pair, it's more like a little bit of a sock that he has worked on. Thus, the opportunity cost of making a t-shirt is making a fifth of a pair of socks. Our second producer, Liz, also runs a clothing factory. She also only produces socks and t-shirts. The only difference is that in a given hour, Liz can produce either 30 pairs of socks or 30 t-shirts. Thus, she takes 2 minutes to produce a t-shirt and 2 minutes to produce a pair of socks. Thus, she could either use 2 minutes to produce 1 t-shirt or 1 pair of socks. Thus, her opportunity cost of producing a t-shirt is a pair of socks, and her opportunity cost of producing a pair of socks is 1 t-shirt. On the graphs below, we can see Joe and Liz's production possibility frontiers. Essentially, Joe can produce at any point on or inside his production possibilities frontier, and Liz can produce at any point on or inside her production possibilities frontier as well. Neither of them can produce outside of their respective production possibility frontiers. So we've established that both Liz and Joe have different opportunity cost of producing socks and t-shirts, and both can produce different amounts in total. If we look at socks alone, Joe has to sacrifice making 5 t-shirts for every pair of socks he makes, while Liz only has to give up 1 t-shirt for every pair of socks she makes. Thus, since her opportunity cost of producing socks is lower, we can say that Liz has the comparative advantage in producing socks. On the other hand, it costs Joe a fifth of a pair of socks to produce 1 t-shirt, while it costs Liz a full pair of socks to produce a single t-shirt. Thus, since Joe's opportunity cost of producing a t-shirt is lower than Liz's opportunity cost of producing a t-shirt, we can say that Joe has the comparative advantage in producing t-shirts. As for absolute advantage, both can produce the same amount of t-shirts if they focus all their efforts on t-shirt production, but Liz can produce more pairs of socks if she specializes in socks. Thus, nobody has the absolute advantage in terms of t-shirt production, but Liz has the absolute advantage in terms of sock production. The information we extracted from the problem can now be applied to our economy in order to make it even more efficient. We get Joe and Liz to specialize in producing whatever they are more efficient at. Joe has the comparative advantage in producing t-shirts, while Liz has the comparative advantage in producing socks. Thus, Joe will only produce t-shirts and Liz will only produce socks. They then trade with each other. Let's pick some random price that they will trade at, say 2 t-shirts per pair of socks. On the other hand, this would also mean that 1 t-shirt would trade for half a pair of socks. For Joe, this is a good deal, because if he were to produce socks by himself, it would cost him 5 t-shirts to produce. Now he only has to pay Liz 2 t-shirts per pair of socks. This is also a good idea for Liz, because if she were to produce t-shirts by herself, it would cost her a full pair of socks per t-shirt she made. If she trades with Joe, she only needs to pay him half a pair of socks to buy a t-shirt. Both Liz and Joe can buy the good for which they do not have a comparative advantage in producing from the other person. As a general rule of thumb, if the trading price of the goods are less than the opportunity cost of production, then both producers will gain from trade. Liz gains from trade because she can buy t-shirts from Joe at a lower cost than her own opportunity cost of production. And Joe gains from trade because he can buy socks from Liz at a lower cost than his own opportunity cost of production. In essence, if they trade, they can consume outside of their production possibilities frontiers. Do keep in mind, though, that they do not by any means produce outside.
Meet Lilith. She owns a small startup tech company that manufactures smartphones and tablets. Lilith has some important business decisions to make concerning the allocation of her company's resources over the next fiscal year. A large part of her decision-making analysis will concern calculating and assessing opportunity cost. You can think of opportunity cost as the benefit or value you give up by picking one course of action over another. In other words, the opportunity cost of a decision is the difference between the value you receive from pursuing a course of action and the value that you would have received from the alternative you did not pursue. Let's look at Lilith's tech company to illustrate the concept. Lilith can use one day to manufacture either 100 smartphones or 75 tablets. If she chooses to manufacture the phones, the opportunity cost is the difference in profits of producing 75 tablets. On the other hand, if she chooses to manufacture the 75 tablets, it costs her the difference in profits of manufacturing 100 smartphones. We generally want to analyze opportunity costs in terms of investment, whether it's a person or a business making that investment. We can express opportunity cost in terms of a return or profit on investment by using the following mathematical formula. Opportunity cost equals return on most profitable investment choice minus return on investment chosen to pursue. Unless the investment returns are fixed and practically guaranteed to be paid, like a U.S. Treasury bond you intend to hold to maturity, you'll have to base your calculation on the expected returns. For example, on average, the stock market may have an annual return of 8%. But that doesn't mean your stock portfolio will return 8% this year. Now let's apply the formula to an example. Lilith's company has a 10% return when it sells smartphones, but an 18% return when it sells tablets. Let's plug in the numbers and see what happens. Opportunity cost equals return on most profitable investment choice minus return on investment chosen to pursue. Opportunity cost equals 18% return on tablets minus 10% return on cell phones. Opportunity cost equals 8%. If Lilith orders the production of smartphones, she'll have to give up the opportunity to earn an extra 8%. Of course, we are assuming that there is sufficient demand for tablets to expend all Lilith's production capacity on tablets. You can use an opportunity cost analysis to help you decide how to best capitalize a business. A business's capital structure is simply how a company finances its operations. Capital structure may involve a mix of long-term debt, short-term debt, and equity. Equity is the infusion of capital into a business through the sale of shares of common stock or preferred stock.
Whole societal scenario where the production possibilities curve or production possibilities frontier is fixed and the choice will be some point on that fixed curve stems from the original assumption that the resources are fixed. Just as a quick recap, what are the categories of resources? Remember, land is any natural resource, labor is any human service, capital, which is not money, is machinery and equipment, and the last category is entrepreneurial ability, where the entrepreneur is someone who, 1, recognizes a profit opportunity, 2, is willing to accept risk, and 3, is able to organize the other resources. But what if the resources aren't fixed? If resources change, what happens to production possibilities? The answer, of course, is it depends. If there are suddenly more resources, then there is a greater capability to produce, and the PPC moves outward or shifts to the right. Now, just to illustrate a side point, let me call the two broad categories of output agriculture, like wheat, and manufacturing, like computers. These categories are often used in production possibilities models because they use resources differently. Agriculture tends to be more labor intensive, whereas manufacturing tends to be more capital or machinery intensive. Why does this matter? Well, I just wanted to point out that underlying resources changes won't necessarily result in a nice, even, parallel shift of the production possibilities. Consider this. Suppose we're producing efficiently using all of our resources operating on PPC1. Then suddenly, someone discovers a fabulous new fertilizer that doubles crop yields. What happens to the possible agricultural output when you use all of the existing resources, plus you add this fabulous new fertilizer? You can now produce much more wheat than you could before. But what happens to the manufacturing output when you use all of the existing resources and then add fertilizer? Probably nothing. So the new PPC, PPC2, does illustrate an expanded ability to produce, but it's an uneven shift. For now, though, just to keep things simpler, I'm just going to show even parallel shifts. So where were we? Okay, an increase in resources will result in an outward shift of PPC, demonstrating a greater ability to produce. Okay, then what happens if resources decrease? Fewer resources mean less ability to produce, so the production possibilities will shrink or shift inward. Now I want you to think about something. What does it actually mean to say that there's an increase or a decrease in resources? How does it happen? More specifically, how would a society see more land, more labor, more capital, or more entrepreneurial ability? In this table, I've gotten you started. Now you complete the rest. Next time.
In this lecture, we're going to be discussing the economic problem. We'll be looking at the reason why economies exist in the first place. The syllabus includes describing the production possibilities curve. We'll also define allocative efficiency and look at some of the costs of economic growth. We'll see the benefits we get from trading with other countries. And finally, we'll examine two different types of economies that exist in today's world. Let's start by talking about the production possibilities curve. To explain the concept of the production possibilities curve, let us imagine that we are in some economy where only two goods are produced, food and clothes. In this economy, there is no international trade and no government either. In our economy, the production possibilities curve is showing us the upper bound, or upper limit to production. We can't produce outside the production possibilities curve because we don't have the resources to do that. Any point inside the curve is attainable because it is below the maximum possible production. Point A, for example, lies within the curve, and thus we can produce at point A. We can produce the quantity of clothes and the quantity of food at the same time because we have the available resources to do so. Any point on the production possibilities curve is also attainable. Point B, for example, lies on the curve. We are able to produce the quantity of food and clothes that is specified at this point. Point C, however, lies outside the curve, and thus we can't achieve this point. We don't have the resources to do so. The production possibilities curve represents scarcity because points outside the curve are not attainable. There is a limit to the amount of resources that we have, so we need to choose how to use them. This is the basic idea of scarcity. Production efficiency means that we are producing a good at the lowest possible cost. Any point on the production possibilities curve is considered to be productively efficient. All our resources are put to use, and so we are able to devote our best resources to the production of each good. Any point inside the production possibilities curve is considered to be inefficient. Let's think about it logically. We can move from point A to point B. This makes sense because both points are inside the production possibilities curve. You will notice, though, that to move from point A to point B, we don't produce any fewer clothes than we did before, but we are able to produce more food. This means that we had extra resources that we weren't using before. Resource use wasn't efficient because all our resources weren't being used. Thus, we couldn't have had productive efficiency at point A. Keep in mind that point B is still within the curve. Even it is still an inefficient combination of production of food and clothes. If point B were on the curve, then it would be considered efficient. The production possibilities curve illustrates a trade-off between our two goods. Let's say that we are producing on the curve at point A, and we want to move to point B because we need more food. We can see just by looking at the graph that in order to produce more food, we have to produce less clothes. This happens because we have a limited amount of resources. If you remember from a previous lecture, the resources in an economy are land, labor, capital, and entrepreneurship. We don't have an infinite amount of these resources, so we can't just continue to produce as much food as we want. There is a limit. And if we want to produce more food than before, then we have to divert some resources away from producing clothes and towards producing food. We'd have to pull workers away from clothing factories and send them to farms, for example. Opportunity cost is defined as the highest valued alternative foregone. This just means that whatever you're giving up in order to get something else is considered the equivalent of the cost. If you don't understand the next little bit, don't worry. I'll clear up any confusion with an example. Just bear with me. Opportunity cost is seen as a ratio. It is the decrease in the quantity produced of one good divided by the increase in the quantity produced of the other good as we move along the curve. Because this is a ratio we're talking about, the opportunity cost of producing more clothes in terms of food is simply the reciprocal of the opportunity cost of producing more food in terms of clothes. Like I said, just bear with me, this will all make sense in a minute. We can see that the opportunity cost of producing a good increases as the quantity of that good being produced increases. This is seen as the curve steepens. The logical reasoning behind this is because not all resources are equally productive in producing each good. If I ask a chef to start working in a clothes factory, he may not be able to produce as many clothes as a seamstress. Now to clear up any confusion, let's take a look at a concrete example. Let's say we start at point A and want to move to point B. Now we are producing one additional unit of food and one less unit of clothing. The opportunity cost, as we defined before, is the decrease in the quantity produced of one good divided by the increase in the quantity produced of the other good. So this would be equal to 1 over 1. The opportunity cost of producing one unit of food as we move from point A to point B is 1 unit of clothing. Now let's say that we move from point B to point C. Well, now we have to give up 10 units of clothing to produce one more unit of food. The opportunity cost here would be 10 over 1. This illustrates the fact that in order to produce more food, we have to start giving up even more clothes than before. If we want to go from point C to point B, the opportunity cost would be 1 over 10 units of food. This is the reciprocal of the opportunity cost